Hello, Pierre. So,
Hello, Yoan.
thank you. You're actually part of Saint-Gobain
Yeah.
Research. But actually, what is your role within the research department, within the research Saint-Gobain?
Well, I'm working for Saint-Gobain Research as a research engineer, and I'm mainly focused on thermal comfort study. For example, I'm studying the impact of Saint-Gobain product on the thermal comfort of occupants in buildings.
Okay. Can you tell us about a bit more about Saint-Gobain Research in general and the strategy
Yeah,
here?
yeah, for sure. Saint-Gobain Research is one of the main research centers of the Saint-Gobain group. We are working for all the brands of Saint-Gobain, including, of course, Saint-Gobain Ecophon, but also we are working for Saint-Gobain Weber, Isover, or Saint-Gobain Glass. Our strategy is to develop new products for the user and, of course, innovative products. So we are doing a lot of upstream research. We are working with universities and with a lot of talented researchers.
I believe that, so from what you say, it's like Saint-Gobain is trying to develop and improve sustainable solution for the habitat. Um, but you always keep in mind, and seems to keep in mind, the end user approach. You're always taking care, trying to create added value for the end user. But what are, as a researcher, the tools that you are using?
Well, as a researcher, our role is to really understand and apply the science to produce new innovative products for the end user. And in Saint-Gobain Research, we have a lot of great tools to do this. We have a lot of scientific materials to make measurement, to make characterization. We have a lot of computers to make modeling and simulation. And we have also some place just to exchange with the end users, like maybe you've heard about the Domolab, which is a
Yes, of
place
course.
we can discuss with end users between researcher and architect or building designers.
Um, we saw you today presenting about this new plugin
Yep.
for Terrances. Can you tell us a bit more about the starting point of this research?
Yeah, for sure. Of course, at the beginning of this story, it was just a question from a building designer and acoustician and thermician. When you try to design a tabs building, a building with a concrete core activation, in fact, you face to a problem. If you want to improve the thermal comfort, you have to expose a large surface of concrete. But if you want to improve the acoustic, you have to install acoustic panel just and reduce the surface of exposed concrete. So here the question was, is it possible to combine acoustic and thermal comfort in such kind of building? So to answer to this question, we made some measurements in real building or in a laboratory. And also we worked on a thermal model of the impact of acoustic panel on thermal comfort in tabs building. And this model was included in a new plugin for Transis, which is a software used to model the thermal behavior of buildings.
Okay, so what you are saying is that today the software that thermal engineers are using is not able to do prediction on the thermal behavior when there is free hanging units or complex shapes.
Yeah, exactly. To my knowledge, it's in fact a difficult problem because if you want to install free hanging units, you can play with the layout of all the free hanging units, with the distance to ceiling, with the kind of product, and you have a lot of different physical effect like a radiative effect, convective effect, and it's very difficult for current thermal software to deal with all these effects. So this is why we develop a new model for the Transis software.
Okay, well, I heard you talking about what you call Terrance's type.
Yeah.
Can you tell us a bit more about the characteristic of how thermal engineer will be able to use it? Obviously?
Yeah, for sure. In fact, the type is just the name. It's just the word to say a Transis plugin, and
Okay.
so this new type for Transis will take as inputs some values from the Transis software, like the air computed in the building, like the characteristic of the room, or the ceiling coverage ratio by a free hanging unit. And using all this value, this new type will be able to compute the effect of the free hanging unit on the thermal behavior of the building and the effect of the free hanging unit on the thermal comfort inside the building. So this is two values which may be used by building designer to improve their project or just to know what is the real impact of free hanging units in buildings, in PABS buildings.
Okay, so very useful tools.
I hope so.
Me too. From some discussion I had from some thermal consultants, will this plugin be able to deal with room-to-room thermal exchange?
In fact, the part from room-to-room thermal exchange will be managed by Transys itself.
Okay.
But the new extension just for free hanging unit will be able to manage the free hanging unit in each room.
Okay, great, good tools. But now that you have been working on this and that the project is finalized, what are the next steps, how to say?
Well, for me, because it's a new model, it's good to make a model. It's better to make a good model which reflects reality. So I hope that we can distribute this tool to users, to building designers, to architects, to thermal consultants, and to have their feedback if they find it's a great tool or not, and if they can propose some improvement, because I think it's very important to share on this topic and to improve the knowledge of both architect and research, just to have a very collaborative way to design new products.
Okay, so you are quite actually open to discuss about it,
and
of course. To find, or to say, super user that wants to try the plugins and exchange with you. It's quite
And a part of our project will be to publish the thermal model in a scientific review, a peer-reviewed scientific paper, to distribute this model and to have the feedback of the users.
Well, thank you, Pierre, for this
interview. Thank you, Yoan.
And I guess see you today for other presentations.
Yeah, it was a pleasure.
Thank you.